All right, I know that a few people are still trickling in, but we want to welcome you to the NAIRR Pilot Partner Series. We are incredibly excited to have our third partner with us today. This is the second of our webinar series, and today's presentation is going to be the NAIRR Pilot Partner Neocortex. The way that this is structured is we're going to have approximately about 30 minutes of a presentation and then about 12 minutes of Q&A. So we would really recommend that you submit your Q&A into the little Q&A button that you'll see at the bottom of your Zoom. The session is going to be recorded, so if you feel like you want to rewatch or you didn't grab something, we'll have that posted within about 2 weeks, and we'll send a link to all of the attendees. Cassia, next slide. We'd like to introduce today's presenter, Paula Buitrago, who is the Director for Artificial Intelligence and Big Data at the Pittsburgh Supercomputing Center in collaboration with Carnegie Mellon University. Paula, the stage is yours.
Thank you so much, Alana. So let's start by sharing the slides. So I'm going to replace and just 1 second. There you are. Are my slides visible or not just yet?
Not quite yet. Sometimes it takes a few seconds. There you go.
How about that?
Yeah.
Okay, excellent. Thank you so much, Alana. Very good. So I'm very excited to join the NAIRR Pilots Partner Summer Series. It is my privilege to have the opportunity to tell you a little bit more about Neocortex. As Alana mentioned, I serve as the Director of AI and Big Data at the Pittsburgh Supercomputing Center, which is a joint effort of Carnegie Mellon University and the University of Pittsburgh. And I'm also the principal investigator of Neocortex. So without further ado, any event and talk that we give, we abide by our Neocortex Code of Conduct. We expect this to be a very enjoyable session where we are all welcome and can participate in a healthy way. So before I start talking about Neocortex, just for those of you that might be new to PSC, which maybe not many of you, but Neocortex is offered by the Pittsburgh Supercomputing Center, which is a national supercomputing center that has been around since 1986, and since then has been a leader in high performance and data intensive computing, with a special focus also on data management technologies, software architecture, and all in all, with the goal of enabling groundbreaking science by using advanced computing technologies. PSC is also a big player in cybersecurity, and it's part of a Center of Excellence funded by the National Science Foundation on cybersecurity. Also has a number of collaborations through NIH and other agencies. Now, let's talk about Neocortex. All the slides moving forward is about Neocortex. So Neocortex is a category 2 type system, which was proposed in response to solicitation 19587. And category 2, I just want to highlight, is a system that is not expected to be production level just yet, at least not at the beginning. Neocortex at this point in time is already in the second phase of the project, which is already transitioning or already offering services at production level. But what characterizes a system like Neocortex, with it being a category 2 type system, is that it offers an innovative or forward-looking capability, right? So Neocortex captures certain technology that is expected or is very promising, and the goal here is to make it available to the open science national community and power a new type of science or advance specific goals. So Neocortex is offered certainly through the award offered by the NSF, which is 2005597, and it's also offered or brought to the community in collaboration with Cerebras and Hewlett Packard Enterprise. Up to date, the project has been awarded $12.25 million, and it has been running for years. So it's sort of on the production phase as mentioned. So there was an initial testbed phase, now it's a production level. So let's talk about specifically what Neocortex offers to the community. So Neocortex is, well, there is a hardware or like an environment, a computing system, Cerebras CS2 servers, which are very tightly coupled with an HP Superdome Flex. So in each of the Cerebras CS2 servers, we have what is referred to as the wafer scale engine, which is a chip designed by Cerebras and is the largest chip that can be built. So it uses the whole wafer. And it has, on the second generation, it has 150,000 cores optimized for sparse linear algebra. So that's already a couple orders of magnitude more cores in a single kind of accelerator than alternatives. So with Neocortex, so in the Neocortex hardware system that is offered is what is here by the orange rectangle. So we have the Superdome flags. They are connected with 1.2 terabits per second with each of the Cerebras CS2 servers. And then there is an integration with the Bridges 2 supercomputer, which is also available and offered by the Pittsburgh Supercomputing Center. But then this integration is at the data level. So the Ocean file system and the Jet file system that are offered by Bridges 2 are mounted on Neocortex. So users that come to Neocortex, they can see all their file space that will be on Ocean and Jet. Since late last year, the Neocortex system also includes access to the Cerebras CS3, which is the latest generation of the wafer scale engine. And that access is through the cloud. So on-prem, we have 2 units. And then on the cloud, there is access to one Cerebras CS3 unit, which allows researchers to get access to the latest and largest AI models. So in particular, with the wafer scale engine 3, there we have additional compute cores, in this case, 900,000 compute cores, additional on-chip memory. It went from 40 gigabytes to 44, and enhanced specs. But more importantly, the ability to run some of the latest and most popular AI models on this chip. This is how the system looks like. If you come to visit Pittsburgh and you want to have a look at our machine room, we are happy to offer tours. As a matter of fact, last week we concluded a 1-week-long workshop where that was delivered in collaboration with a couple more NSF testbed systems, and a big highlight of the week was the machine room tour and people coming and joining and getting to look at how these Cerebras servers look like. They are stacked in a single rack. And then what we have here in the picture in the middle, what we have on the right is the Superdome flags. Something that is pictured or depicted here and is right in the middle, in between the 2 racks that are in the front, is the cooling device unit. So Neocortex is water cool, and you need the space of 2 racks to have the cooling device unit and also the reservoir that powers the CDU. We also picture Bridges 2, considering the integration of Neocortex with Bridges 2. And something that is very important here is that the way Neocortex was envisioned and has been offered to the community is as an environment where researchers can come and use the wafer scale engine to accelerate some of the most demanding and largest AI models out there. And then they also use the Superdome flags to do any tasks that are related to pre-processing or post-processing tasks that are around the AI training workflow or AI inferencing. And the integration with Bridges 2 allows us also to support complex scientific workflows that benefit where you will find regular memory nodes, GPU nodes, and some extreme memory nodes, and then kind of integrate or have a scientific workflow that leverages both Bridges 2 resources and also the resources available in Neocortex, which, as we mentioned, the innovative and very exciting part is the wafer scale engine in the Cerebra server. So why researchers should consider using Neocortex? Well, there are two questions, right? Like why to use Neocortex, and also there is why to consider maybe using another accelerator, which is the wafer scale engine. Here are some metrics, right? There are a number of benchmark efforts that have been published over the past few years that highlight without a doubt that when you're running AI models that are large enough, right, and you compare how fast do they train and also how fast do they do inference on different accelerators, including, let's say, the wafer scale engine or different, well, some of the fastest GPUs, both by NVIDIA or AMD, or also other accelerators like the IPUs and others. So when you run on the wafer scale engine, you can gain a couple orders of magnitude in terms of speed, so which translates to being able to complete your training in, well, minutes or hours as opposed to days or weeks. So the added value of using the wafer scale engine is accelerating that time to science. So if you have a specific training task that you're able to once again complete it in what will be hours or days as opposed to, well, weeks or possibly months, depending on how ambitious is the task that you're tackling. In this case, we also show that it depends on the model. Not all the models are ideal for Neocortex, in particular the ones that are both transformer-based architectures and also very large models. Those are the ones that are ideal for Neocortex or for the wafer scale engine offered by Cerebras. And that, well, as since we are all on the NAIRR Partner Series, it's has been one of the resources available via the NAIRR program. Here I would like to highlight also another excellent use of Neocortex, which is not so much AI related, but is we have also found that this architecture offered by the wafer scale engine is very effective in accelerating simulations where you discretize time and space. So in particular, the animation that we have on the left is a simulation of a fluid environment. It's a complete, well, CFD simulation that was done on Neocortex. And when compared, as we can see on the graph on the right, so the wafer scale engine performance are the green lines, and blue lines are the speed that was evidence or witnessed in a distributed system, so a whole supercomputer at the service of the same simulation. So on the vertical axis, we have logarithmic scale. So here we can see that using the wafer scale engine, a single chip, in this computation, in the CFD simulations, researchers were able to observe an improving performance of a couple orders of magnitude, which is significant. And in particular for this research group from the National Energy Technology Laboratory, allowed them to simulate an environment that was previously maybe too big for a single supercomputer, and also the speed at which they got the results resembled real time. So that can be transformative, right, as you're considering or as you're advancing your research or deploying applications. So with that, I want to highlight like some of the projects that are currently running on Neocortex. As mentioned, Neocortex has these two kind of on-premises units, and then there is the cloud unit. We have researchers from different fields of science, including engineering, physics and astronomy, medical engineering, math, geophysics and geochemistry, chemical science. And as we can see, well, most of them fall under what would be computer science, AI, and well, a big chunk of biological sciences. So in any point of time, there are about like 50 active projects. There has been an uptake in the past month or so, also with our workshop that we recently completed. We got a number of projects also going there. Innovative system, right, and featuring some new hardware. A big part of the whole process was to understand, well, of the project so far, right, after during the first few years, was to characterize the type of applications that are ideally suited for this technology. Because we know researchers by default, when you're considering AI or doing AI training or inference, and the accelerator that by default you would like to use is a GPU, and the idea here is to also consider or give the opportunity to explore alternative accelerators. But then even when you're doing AI or other kinds of or advancing or running other kinds of scientific workflows, there are a specific type of applications that are ideally suited for the wafer scale engine. So we identified 4 types of applications that are listed here. The first is, we call it the Cerebras model to ML models. So Cerebras offers a repository that is publicly available, and that has a list of models to repositories in the generation that is supported for the wafer scale engine 2. The models that are supported are the ones listed right here. So a number of transformer-based models, so BERT, GPT models, Linformer, Roberta, T5, and Transformer, MLPs, and in the computer vision realm, it will be 2D UNet. So something to keep in mind is the wafer scale engine. It's a new accelerator, and initially Cerebras has mainly focused kind of on NLP tasks and transformer type tasks. And then computer vision is more of a recent type of support. So with the wafer scale engine 2, there are a certain number of models that are supported. With the wafer scale engine 3, there is an enhanced list of model support. And once again, both of them are the wafer scale engine 2 and wafer scale engine D can be accessed through Neocortex through the on-prem solution and also through the cloud solution. So first type of applications, the Cerebras model SU, ML models, listed right here. This type of application runs on TensorFlow and PyTorch, right? And there are specific kind of steps that need to be taken towards when you're migrating maybe your code to run or be compatible with the wafer scale engine, depending on the specific functionality and approach that you use on these machine learning frameworks, the process of porting is less or more involved. But in general, there is a number of functionality or a subset of functionality that is supported, and there's a way to kind of adjust it and port the code, or that has been our experience. Now, with the second type of application, we have the ML models that are similar to one of the models in the Cerebras model SU. So will be models that are a combination of layers or operations that are supported by Cerebras, by the software stack. So there is a very clear, complete list of what are these routines and layers and operations that are supported. So it will be kind of models similar to those in the model SU, but then that need a specific adjustments. So the type of application 1 or 2 are the ones that would pertain to artificial intelligence. If we talk about other type of scientific research that is not necessarily using AI models, but is more general purpose simulations and similar, then we are talking about application 3 and application 4. Cerebras makes available a software development kit, the general purpose SDK that allows basically to code very close to the machine. So it's analogous to coding on the GPU with CUDA. So it's more flexible and allows you to do many more things, but it does require more involvement since you will need to kind of code all the functionality from scratch. Normally, we recommend the SDK for teams that have the resources in terms of the expertise and the availability of time to really tackle kind of coding everything from scratch. So you could do in principle AI with the third option. It just would be a little bit more involved, and it would be akin to not using a machine learning framework and just coding everything from scratch. It's doable, but it's more involved. Now, the fourth type of application leverages an API that was developed by the National Energy Technology Laboratory. And it's an API that builds on top of the CLCL, which is the Cerebras language. And it just makes using or well solving systems that can be um, described with structure grids and also that are, I don't know, represented and solved through PDEs and ODEs, uh, makes it easier. So there are a number of functionalities that just allow for the specification and solution of those type of systems. All of the links to where you can find more information about each of these tracks are included in the slides that I trust will be made available to all of you after the presentation. So talking a little bit more about the type of applications that are supported on Neocortex, and some examples of what can be achieved with running these applications. And I think more and more is well known, like how transformer style models such as BERT and others, and also Llama and whatnot, are very important and can be used not only for large language and well for natural language processing, but you can adjust it. And we will be talking about a specific application where that has been done. But with these models, you can do sequence classification, annotation, generation, sequence mapping, and also representation learning for biological sequences, right? So, and the applications of these models are just very wide and not limited to NLP, since you can take one of these transformer models and then attach a downstream model and have it achieve or like perform a different task. And as we have seen over the past, well, the tendencies these days is to really integrate a number of models and kind of organize them in such a way that you can tackle different tasks. And now, here in this slide, what I would like to highlight is that by using the third generation of the wafer scale engine, you get access to, well, the models, sub-models or the sample models that are ready to be used. Well, the list is a little bit larger. So in this case, we have support also for different kinds of llamas, different sizes, also Lava, Mistral, we have Mistral of experts, multimodal, T5, Falcon, and well, DPO, and there's also support for vision transformers, right? So which is a great model out there for computer vision task, should you need it. And one thing that I want to stop here and mention is that Neocortex is an excellent system. It's not necessarily for everyone, because not everybody needs a system this powerful, right? So if you're perfectly well served with more models or a GPU or another type of accelerator, that is the ideal solution for you. So, but if you're a researcher that uses any of these models and really would like to speed up the training or the inference times that you're getting, Neocortex would be ideal, especially if you use one of these specific models, because basically it's taking one of these off-the-shelf models, adjusting, of course, the data pipelines that come in and out of your model or your training or inference, and then running and really enjoying the couple of orders of magnitude that you would get in terms of speeding your research. So one example of what has been achieved using Neocortex is the use of a model like Inverta, right? So, well, here is using well, Converta is basically using the Roberta model and to process strings that are, well, referred to as smiles, which are a text representation of molecules. And we have seen that by using Neocortex, right, the speed times of achieving or using Roberta to later on predict molecular property prediction is significantly enhanced. So I'll be talking more about a specific work project that was advanced using Neocortex and that was recently awarded. So, but then overall, I mean, maybe I shouldn't spend so much time here because this is NAIRR and I'm looking at the clock and I have still a few minutes. But just to give you a sense, well, this is more about like the third type of application, right? So the Cerebras SDK, where you, as you're coding, you're basically coding very close to the chip and the machine, and you would you have all these 850,000 optimized or individually programmable processing elements, right? So the cores that we talked initially you basically get a grid of all those cores, and you have to, or you're able with this SDK to tell what happens at each point of time. So it's more control, more flexibility, but also higher effort. And once again, mention they offer the WFA type of applications. It just allows you to do that type of work, but it has some routines and functionality that simplifies you are not that close to the machine, a little bit higher, but not as high as if you were using, let's say, a machine learning framework. But this for type of application is more general purpose and has been more used for simulations like CFD and similar. So some other numbers, right, like that were recently published in some work that we shown at PERD, right? So in terms of times that you can get with when you use Neocortex as opposed to other accelerators. And here we even got these results when using a simple fully connected network. But once again, you can see that the results are orders of magnitudes of gain speed that certainly help with time to science. Let me see, I'm looking at the clock. Still have a few minutes, sorry. Now, I would like to maybe use the time that I have left to talk about a specific project that was recently presented in the PER 25 conference, and it was awarded with the Best Short Paper Applications and Software Award. And it's a project that was advanced Dana O'Connor, who at the time was a machine learning research scientist at PC, and also our summer intern, Yin Soon, and myself. And here what we aim to accomplish is study the effect of text representations in the task of property prediction of organic molecules when you're using a transformer model, in this case, Roberta. So in general, it has been demonstrated that transformer type models, LLMs, and LLMs are very good at predicting key properties of organic molecules. But then it has been demonstrated that they're very effective, and whenever you use the model and have it do a classification task. Now, there are specific properties that require more of a regression task, right? So let's say, talking about density or similar, when the output that you need or you would like is numeric in nature. So the goal of this project is to test the ability of the model to do a regression task, right? By using a downstream model that allows it to have these regressive capabilities, plus also consider what would be the impact of using different text representations, there are a number of options out there in terms of like, how do you represent the molecules? And given that we are talking about LLMs and transformers type models, there is a need to represent each of your entries using text format. Right, so by default, and one of the most popular text representations is smiles. With smiles, a molecule like the one that we have on the right would be transformed, or like will be represented by the string that is seen on the bottom. It just represents molecular structures using atomic symbols and connectivity. So it lets you know that there is nitrogen and how many of them there are, and then there is a connection with carbon atoms. And it's very compact and popular. However, one of the downsides of this text representation is that a single molecule can have multiple valid smiles representations. If someone wants to tell me about the time, let me know, because I still have a few slides. 1 minute? Okay, so I'm gonna go, and the slides will be made available to all of you. So what we did in this project is explore two other type of text representations. One of them is called selfies, and the other one is called Inky, which are a little bit more complex, a little bit more precise, like there's no multiple, or like there is one-to-one in terms of representation and the molecules, and seeing the effect on the ability of Roberta in predicting a specific, the density of the molecules. So what we found that was very interesting results, where certainly the text representation has a big impact, especially when you are using the most kind of precise forms of representation. Now, one of the downsides or challenges is that for a number of molecules, there are not any, well, depending on the molecules that you're using here, we also kind of focus on a data set that is high explosivity data. And so always having all the data available to train these models is significant. But with using Neocortex, this study was able to be achieved, and also different metrics were explored where we explore like the parity graphs and also consider how the mean absolute error sometimes can be misleading. So I do encourage you to check the paper is out there, is published, and once again was awarded and was made possible thanks to Neocortex. And the idea here is to give you an example of what can be achieved using the Neocortex. Now, with that, Neocortex is available via Access and NAIRR. There are a number of support resources. I didn't get that slide in, but I want to say like there are a number of ways through which you can get support. We have office hours every Wednesdays at 2 p.m. And also there are office hours that you can request on demand. So you go to the Neocortex page and find the Calendly, and you can select which day and time works well for you. If you add a short description where you say, I want to get guidance on this, we will make sure to get you the expert support that you need. And with that, I don't think we have time for the Emily's example, but we can go then on questions. Thank
Awesome.
you.
Thank you so much. This was a fantastic presentation. So we do have a couple of questions already. And Paula, if you want to leave your slide up, the one prior to this, which provided, I think, some links to, yes, that would be fantastic. So people can sort of peruse that and see links that you've placed for questions and documentations. So I'm going to start off. We have an anonymous question. And so they say, I see that Cerebrus is also listed as a NAIRR pilot resource with the wafer scale engine 2, so the CS2 AI accelerator clusters available up to 16 CS2 systems per cluster. What are the key differences between the Cerebrus offering and Neocortex CS2? And what do those differences mean for the types of use cases that are best matched to each?
Yes, I think that is a fantastic question, and I'm very glad that this question was asked because it gives me the opportunity to reiterate like why to use Neocortex, and yeah, when to go to Neocortex and when to go to the Cerebrus offering. So Neocortex offers this supercomputer that was described in this environment, but not only we have found this critical to also leverage and support researchers, right? So we have a specialized well, research scientists. So as mentioned, I mentioned Dana, who was one of the main authors of the project I highlighted. So machine learning research scientists that work closely with researchers, getting them kind of familiar and getting them to understand how to best use the wafer scale engine. So the way we have agreed with Cerebras and also Argonne National Lab, because they also make available Cerebras units to the NER via their LCF AI testbed. Neocortex can be the entry point, or is ideally suited to be the entry point for researchers that are just becoming familiar with the wafer scale engine. So not only you get access to the hardware and the technology, you also get access to well, support of machine learning research scientists that have been using the system for a while, and that can help you get comfortable. And if you're well served with one or two of these units, the idea is that you are well served by Neocortex and will have great support. Once you get past, or your needs get past one or two of these units, we are happy to guide you through kind of get to either get the Argonne National Lab solution or go to the clouds. Now, through Neocortex, you also can use, as we mentioned, the Cerebras cloud, and then scaling up would require just complementing or supplementing your proposal or your allocation with Cerebras cloud resources, and you will be ideally like perfectly suited. So we are happy to assist researchers that are getting comfortable and want to get to know the wafer scale engine. So that accompaniment is what kind of what differentiates the project. I hope that addresses the question. Please follow up if something wasn't. Uh,
Absolutely. Yep. Please feel free to drop your questions in and any follow-up necessary. So I have another question for you. So the comparison of the CS2 device performance is currently against older GPU models. So for example, the V100s and the A100s. Is there similar data comparing this to say Hopper, Blackwell, or AMD?
Yes, we do have, and in particular, so we have a great collaboration with ANL. They also do a lot of benchmarking. So we do have some more recent results on benchmarking. I'm happy to share them. And yeah, you're very right. Whoever pointed it out, like we are not trying to compare like this is comparing like the older generation at the time of the buffer scale engine, which was the second generation, which is still a very powerful system. It's very useful for many researchers out there with what were the some of the GPUs, later GPUs at the time. Now comparisons of wafer scale engine 3 with the latest version of GPUs, it's also valuable. And I understand ANL is, if they have not published it yet, they are about to publish some more recent results. I'm happy to share those links as part of kind of these resources. You still see significant enhanced performance, and in particular with inference, the wafer scale engine at this time is the fastest. I'm not saying it will continue to be the fastest for, uh, I mean, forever. It's impossible to make that assertion, but right now it's a very powerful system that is available for researchers to accelerate their AI workflows.
Thank you. And then we have a final question, which is, and you've sort of touched a little bit on the Cerebus processors, but have results from Neocortex help shape the roadmap for potential future Cerebus processors?
Well, we do have a very close relationship with Cerebras, so we meet with them weekly. And at a chance, we have also person meetings. More recently, like 2 or 3 weeks ago, we were in the Bay Area meeting with them. They work very closely with our researchers. So whenever you request, well, office hours, they are not on our Wednesday 2 p.m. office hours, but if a researcher goes and uses Calendly and requests a session and indicate that they need support with a specific model, we normally engage as a reverse engineer. So there is very active and fluid conversation with Cerebras. We have been working with them since Neocortex was proposed in 2019. That's already a few years ago. So we have helped guide Cerebras in terms of what are the needs of the research community, at least in the United States, right? So through engaging with the researchers, that has informed, well, or has allowed Cerebras to know what are the needs of this community. So in that regard, some of their decisions, I would say, have been informed by this awareness and these interactions. Also, Cerebra, something to point out is it's a startup, so it's a new technology company. So they balance out the needs of the open science community in the United States and other places with also their needs and whatnot, priorities as a company that is in the stage in which they are. So the information has flown, and yeah, we have kind of at times we have advocate for support for specific needs, and more so at the beginning of the project. Uh, Now, I do have to say we have a number of times where with Cerebras, we agree that they would enhance the support for a specific functionality, for instance, with vision transformers. That was an example where the researcher, one of the main authors of that type of model, first started through Neocortex. And with Neocortex, there was this facilitation and conversation going with Cerebras, and that translated to vision transformers being one of the kind of off-the-shelf, very well-supported models out there. So overall, the relationship has been very healthy and has really helped with enhancing the support and to respond to specific needs of the open science community.
Thank you so much again, Paula. This was a fantastic presentation, and thank you so much for being a NAIRR pilot partner. We'd like to also thank our attendees today and let you all know that we typically have about 1 to 2 of these NAIRR pilot partner showcases each month. So please, stand by and look in your emails and on the Access and NAIRR website for upcoming webinars. We're really excited to continue to share these with you moving forward. So thanks again to Paula. And thank you to everyone. Have a great rest of your week.